Okay, so from today onwards, we are going to look into the DevOps. This particular training session covers from the beginning level till the expert level. Okay, so you guys have to pay attention to each and everything. So it's better to have a notepad and pen with you instead of typing in the notepad. So have a separate notebook and pen. So write down few details which I'll tell you, and whatever we cover most of it, but there are a lot of things. DevOps is a C, and we are just going to cover what you want to learn on the DevOps. Okay. um, so just minute of details noted down in your notepad, and we'll cover most of the things from what you want to know as a beginner. To become an expert level, you need to do more practices. So that is something end of the training will I will provide you with the projects. So by doing it on your labs, you will learn more about it. So this comes with the experience. So after the training session, you will feel like you know everything, but while you practicing it, step one, step two, step three, you will stuck. Okay, again you need to start from the step one, step two, step three, step four, then you will go back to step one. So this is how DevOps is and Linux is. So if you're already an expert, then it's fine. But since we are starting, I'm giving you just a heads up or a note kind of thing. You might feel, oh, it's so simple, but it's not as you think. Okay, I'm not scaring you guys, but that's a fact, practical reality. Okay, so so I know we all know each other, but let's say hello to us. Uh, so this is July month's batch. We are going to cover DevOps. So I'm the trainer Gautam. So this is month July. I'm recording it, and you guys can introduce yourself.
Cheers to new batch.
Sorry.
Like, cheers to new batch.
Okay. No, you just say your name and experience and your background, maybe educational background, not other family background.
Hi, my name is Suman. I'm from Bangalore, and I've been working in technical support for last 1 year. And,
So myself, Gautam, I have almost 12 plus years. Although I mentioned as 11 plus years, I have 13 plus years of experience overall. And I involved in freelancing training. So once I settled down in my full-time job, I kind of paused it, and now I have resumed it. So, so I have, like I said, I'm from Tamil Nadu, a place called Theni. So I did my undergraduate, postgraduate, undergraduate in technical field, postgraduate in finance and HR management. So then I joined a startup. Then after that, I worked for HCL for almost 1.5 years. Then I'm currently working with IOPEX for over 10 years now. Uh, so in between, I gave trainings, and I'm also a PMP certified practitioner. So I have vast experience with digital marketing, working with a lot of clients, plus NOC DevOps environment along with product support. So now I'm working with the firewall um, support. So this is about me. Okay, so what are we going to cover in this course? So in a nutshell, so it's a DevOps. So we are going to divide this into three sections. So one is operating system, lab, programming, and scripting. So we are going to learn this as one section. So in this section, I'm going to give you introduction about the DevOps, and we are going to set up a VM lab. So this is completely physical VM. Okay. Physical VM in the sense we are going to use our own laptop to set up this VM. Okay, so in the VM we are going to install at least two operating system, which is with Linux itself, two flavors of it, Ubuntu and CentOS. Okay, so we'll look into Linux section what are all the flavors available. Then we are going to learn bash scripting completely, and Python to some extent. Okay, so and the basic networking. So while we do all these things, most of the networking concepts are covered, so not up to you completing the CCNA module, but to some extent that you want to know how DevOps works. Okay, and then second section we are going to learn DevOps tools, which is Docker, Jenkins, Maven, Ansible, Terraform, Kubernetes. So Docker and Kubernetes are the container service tools. So why these two? Because these two are the highly top adopted container service in the current market. So Jenkins, Ansible, Jenkins it's a CI/CD, and Ansible, Terraform. These are some of the configuration management which we will learn. Okay, so you need to have a lot of patience to understand and practice. Okay, so you need to practice more of this. So mostly this Docker, Jenkins are one-time setup, and Terraform also. So, but for understanding this, we need to have a lot of practice. Then we'll touch base on the cloud. So same VM, what we are going to do, that we are going to do in the cloud space. So the difference between the cloud and this physical thing is, physical is DC, which you have in your own system or in the company's premises or somewhere physically maintained in the uh, what maintained by the providers or the company. Okay, cloud is something third party offers us, and we can host anything like a software, even this Jenkins or spinning up a Linux. So all these things we can host and maintain in the third party cloud service. And benefit of using cloud is you can host on multiple locations. Okay, you can create a redundancy. So if uh, if you are hosting AWS, in AWS, if you are hosting a software, for example, or if you are storing your file, any of your file, like say for example a PDF file that you want to store, if you are storing it in your own laptop, what if server crashes or hard disk crashes? So you don't have option to recover. But in cloud you can host it in multiple locations. Say in India, Mumbai has a location, you store one PDF in Mumbai location, and again you can copy and paste it, I mean duplicate that in the North Virginia location, which is in US. Say if any of the one location goes down, you can still retrieve the uh, document or anything in that matter from a different location. Okay, that is the uh, one benefit of using cloud, but there are multiple benefit. So what are we going to cover is AWS cloud. Okay, some of the cloud networking tools, Git, and some add-on projects. Okay, so that's only few things I mentioned about cloud, but we are going to learn a lot of things and a few services that involves in uh, DevOps. Okay, any questions on this, guys?
No, sir.
Okay, so what is a DevOps? So I'll read this thing. Okay, so DevOps is a software development approach. Okay, so that emphasizes collaboration, communication, and integration between software developers and IT operations. It aims to shorten the software development lifecycle, improve the speed and quality of releases, and increases the efficiency of software delivery through automation and continuous feedback. Okay, so DevOps generally reduces the time and improvises the collaboration between multiple teams. Okay, in order to reduce the time of development, plus increasing the quality of the software. Okay, so this is just an introduction and a definition of DevOps. So for understanding the DevOps, let's go back into basics. Okay, so there are a few phases or concepts of the software development. So there are 5 to 6 different phases. So it's 7 phases. Okay, uh, one is the first phase is requirement gathering. Okay, so before that I'll give you a small story. Let's say, for example, let us take a v3, okay, as an example. uh, let me take me as a client, or let's take Prem as a client. Okay, Sumant as a software development team, and me, I'm working for the from the operation side. Okay, let's say Prem has a requirement. He founded his own company. Okay, he's selling something online or selling a lot of products online. So he approached a company. So in that company, Sumant is the software developer, or he belongs to software development team. So Prem has a requirement. He is selling 10 to 15 different products online. So he wants a software to be made right from website till the backend operations. Okay. So what Sumant will do is he will go and gather the requirement. Okay. So the requirement includes what features needs to be added, who are the audience for that, who are going to use, and what is the usage, what is the user requirement, and what is the market state. Okay. So Sumant will go and understand, not Sumant's team will go and understand what is the requirement from the customer. Okay. So after gathering all the requirement from the frame, so what Sumant will do is he will work with his team and do the planning. So what is the cost, and what is the resources needed for the development, and what is the risk involved. Okay, risk may be internal risk, external risk, all those risks involved. Okay, so cost, resources. So these are all some of the initial planning that Sumant and team will do. After that, what Suman's team do is they involve their architect to design the uh, software. Okay, and they'll do the roadmaps. Okay, so in 1 month, what will we do? In 2 months, what will we do? In 3 months, what will we do? So these kind of planning and uh, roadmaps they will do. Okay, so that belongs to the designing and architect, the designing team, and they will, in the architect team, they will do all these things. Okay, so then comes the actual development. So Suman's team should have a lot of developers and software developers. They write a lot of codes. Okay, say for example, Brain's requirement might needed only 4 or 5 software developers who will code for 3 to 4 months. Okay, so after doing all the codes, they send this code to the testing team. Okay, so testing team will find the testing, I mean, they do the code testing using tools. There are a lot of automated tools now, but manual testing, they do that code testing. They identify, their only task is to identify defects and bring that to that development team, and they do the bug fixing. After doing the testing for multiple times or multiple iterations, what they do is they'll move the uh, code to the production environment. So from the production environment, they will deploy it to the production environment. Okay, so code will be merged with the production, and from the production they will deploy it to the product, actual product. From there it will go live. Okay, so after going live, there are a lot of maintenance similar to our vehicles. So after production, after the sales, like this team has to do a lot of maintenance. Like they need to monitor uh, throughout. I mean, they need to set up a team to monitor the performance of the software, and if it is a website, what is the uptime, how long it is up, and is it handling all the traffics or not. So a lot of infrastructure and maintenance related work will be done at this particular pace. So these are all the 7 paces that a software will go through. Okay, understood, guys?
Yes, sir.
Okay. So this is the key. So requirement gathering, planning, designing, development, testing, okay, deployment, and uh, after deployment, maintenance. Okay, these are all the concepts. So before this DevOps, there are a lot of development model that were in the market. Okay, so waterfall, agile, spiral, big bang. So there are a lot of models that companies adopted to develop and deploy the software. So waterfall, that was the widely used earlier, and many companies moved to agile. Okay, and now company is adopting to the DevOps. That is how DevOps is taking his chances now in the present market. Okay, so it's all the evolution. DevOps, if you think this is the model which is there from long time, no. Okay, so everything is a evolution. So waterfall, then agile, company adapted to agile because they found it agile is better than or faster than the waterfall model, and now DevOps is much more faster than the uh, other models. Say if you look at the difference between all the models, there are not much difference.
Just a minute.
Yeah, sure.
Prem, I just wanted to mute.
Okay, he muted.
It was a lot of disturbance. Yeah.
Yeah. I think Pradeep, Prem has to buy a noise cancellation headset.
Yeah.
But it's fine. Yeah, so I'll repeat. Okay, so DevOps is the model, okay, in software development life cycle. That is the evolution of the previous models. Okay, so there were a lot of models like Spiral, Big Bang. Then Waterfall was the mostly widely adopted by all the organization who develops the software. Then comes the Agile, which is faster and quicker than the Waterfall. Okay, now Agile, let's say for example, a development team has taken the Agile methodology but not the operation team, so there were a lot of disconnect and delay from the operation side. Okay, while they fix the development side of the delay. So both the delays are addressed in the DevOps model and completely automated uh, the development part of it as well as the infrastructure part of it. Okay, so that is what DevOps. Okay, so everything is the same. The destination is going to be the same, but when the path, okay, the road path that we are going to take is something different and varies from each and every model. So that is why I put a what lot of bridges with a confused bridges picture on right side of the presentation. Okay, so end goal is we need to deliver the software. Okay, and the road path we are going to take is different in each model. Okay, understood, guys?
Like Agile methodology is similar to DevOps.
Uh, no, both are different. Say in Agile, still they follow this development, testing, and development team, testing team, customer. So they all were collaborating in the Agile model, okay, which was not there in the previous model, previous to Agile Waterfall. So Waterfall, what happens is it happens pace by pace. Say they will gather the requirement from the customer, they'll build the entire software, okay, and then they will test it, deploy it, then go to the customer, they'll show the product, this is the product, but customer will say no, this is not my requirement, I have other requirement, additional requirement, this was my requirement. So a lot of changes, iterations happens. Okay, so it is difficult to adopt uh, to the waterfall model with the fast changing environment or the customer changing, customer requirement changes. Okay, in Agile, what they did is they set a frequency of 3 weeks or 6 weeks, I guess. What they do is they'll design something, they'll code something, and then they go to the customer, and customer, if they have additional requirement or changes, they'll let these people know, and uh, developers will design the codes, okay, make the changes then and there, and they send this to the testing team. And say for example, say if Prem has a lot of requirement, say if today he is having 15 product and next week he is launching few more products, so he has more requirement to further expand or add more features to the particular software, okay. So he will let development team, someone's team know that I have more requirement. So what agile team do is they'll add the requirement to the software, but when they go to the operation team, they don't have the infrastructure for that. So based on the previous requirement, they design the infrastructure to handle only that 15 product capacity software, okay. But when they add 5 more product, they don't have a proper infrastructure. Immediately they cannot go and increase the space and have that infrastructure for the additional 5 um, product to be deployed, okay. And deployment happens every now and then. So when agile team adds one more feature and ask development mean deployment to deploy it, so they don't have a proper infrastructure to deploy it. So it is kind of agile development sector is organized, but operations sector is not organized to accommodate the requirement from the development. You understood the difference?
Yes, sir, I got it.
Okay. It will be confusing little bit, okay, until you understand the whole life cycle of development, okay. um, yeah. So DevOps, it addressed delay from the both side, because agile is already agile. In agile development side of the problems are uh, addressed, and operation side not. So addressing both the problems, they come up with the DevOps methodology, okay. Okay, so waterfall and earlier. Okay, this gives you a bit better picture about it. Uh, so waterfall or earlier methodology, it's not suitable for a changing environment. Say today's pace, 15 minutes, 10 minutes, they are delivering a product. So, but if development uh, equally contributes to the fast pacing environment, uh, only then some companies, any companies could survive, right? So DevOps, I mean, sorry, waterfall or earlier model, they followed a methodology which is not suitable for a fast changing environment. And it, like I said, it may take 3 months, 6 months, even 1 year to make the changes depending on the customer's requirement. So in Agile, the requirements and the iterations, like I said, it is they had check, okay, of every 2 weeks or 4 weeks. So what they do, they go to the customer and gather the requirement. After 2 weeks, what they do, they go again back to the customer and say, this is what we did, do you have any change requirement or changes to be done? Okay, they'll do in the further iterations. So every 2 weeks up to 4 weeks, they do one iterations, and after that they will do the other changes, okay. This is the development side of it. Okay, so new ideas can be accommodated in each iteration, that is which I said, but test can be failed during the deployment, right? So they made a lot of changes. So first week they'll do one change. After 2 weeks, customer gives them another changes to be done, and development team do those changes also. And when they do the deployment, there are a lot of chances that the deployment fails because, like I said, operation team has done that infrastructure for the previous requirement, not for the updated requirement, okay. So there are a lot of challenges experienced by the ops side of the world, and for addressing that, DevOps comes into picture. So you guys understand that, right? So development part, coding, testing, requirement gathering is done and changes will be done. And the operation side of it, they have to maintain the infrastructure to accommodate the challenges, okay, and the monitoring things post deployment. So these are the two what side of the development. So overall model. You guys able to visualize this, right?
Yeah, you can do it.
No, no. Just tell me, you guys are able to visualize what I'm trying to say, right?
Yes, sir.
Okay. Sumant is still confused. Is it?
No, no, no. Got it.
Okay. So,
Like previously, my understanding was like DevOps will follow Agile methodology. I just got a clarity of the improvisation what DevOps has done.
no, no, no. Agile is a different methodology altogether. DevOps is a different methodology altogether. Okay.
Okay, sir.
Okay. So this is just for your understanding. So let's see. When you become a project manager or a product manager, so you will manage the entire business unit. So at that time you need to give a holistic. You need to have a holistic picture of it. But maybe when you start what your career, you will work on one portion of it. Okay, one area of it. So okay, so DevOps. Um, So, like I said, developers have their own challenges, which was fixed in Agile, and but still, operation side of it, they had a lot of challenges. So, to mitigate that or to address those challenges, this DevOps comes into picture. So, operation team and the development team were cross-trained on each thing. So, this is what operations team do to the developers and to the operation team. So they were educated on the development side of it. So the communication, collaboration, and integration, okay, all these things were uh, given like a top priority here. So then they automated a lot of things like code build, code testing, software testing, infrastructure changes, and the deployments. So these are operation side of it. So they automated so all this area in the DevOps model. Okay. Uh, yeah. So after software developers they merge the code. Okay. So there the code build starts. Okay. After building that code, the code will be tested automatically by the testing tool. Okay. Then the changes in the infrastructure will be made automatically. So that thing we will do when we learn AWS. Okay. Say for example, auto scaling is there. Okay. One example. Say if customer has a lot of requirement when they uh, add more and more code to the tool. So infrastructure, if it is designed only to handle the previous capacity, not the updated capacity. So one example is auto scaling. So say for example, if I have only 200 GB of the hard drive in cloud, okay, but my previous requirement itself took 180 GB, and the new requirement needs 50 more GB. Now I cannot go and extend my infrastructure manually, okay, because the code is already in. Okay, they already pushed the code from uh, testing server to the production server, let's say for example. Okay, so that 50 GB, how will we do? So when we enable the auto scaling group, okay, to spin up a few more space to the existing instance, okay, that will add some 50 GB or whatever the requirement that we set. So when we push the code, it will this AWS will understand the requirement and spin up some more space to the existing server. Okay, that is called as auto scaling group, but we will learn it in the AWS section. Okay, so I'll give you bits and pieces of it. So you guys have to connect the dot. So connecting the dot, you will learn while you do the projects. Okay. Fine. So in DevOps world, code building, code testing, uh, infrastructure automation, okay, deployments, these are all automated. Okay. So we will, I mean, this Jenkins, Ansible, Kubernetes. So these are all the automation tool what we will learn in the DevOps course. Okay, in this course. So that is all the operations side of it. Understood, guys?
Yes, sir.
Okay. Sumant, any questions?
No, sir.
Okay. When I look at Sumant only, I see that confused face. Okay.
Like it's a new thing, sir.
Yeah, it's a new thing. It's completely a new thing. Okay, I think this Zoom is going to disconnect. We'll join back the same link if it disconnects. Okay.
Yeah, sure.
Okay. So DevOps. So these are developers, testers, system admin, database admin, build releases. So every other team has come into the collaboration. Okay, to make it success of this particular model. I think in this gap, Prem went for a smoking break.
Yeah. Like he might have connected through phone, I guess. So he has gone to his native, sir.
Oh, okay. I mean, he's using phone hotspot and connected to mobile. I mean, connected in laptop.
Yeah, I guess so. Laptop.
Okay, okay. Mr. Prem.
Yes, sir.
Nothing, man. All right. So, uh, so similar to how what we see in the normal development pace, so it remains the same, but there are 7 paces that a DevOps lifecycle has, which is continuous development. So, like I said, developers, coders will frequently write the codes and continuous integration. Okay, so using tools. So as soon as I write a code, once it is validated, and that will be integrated in the what in the package. Okay, then it is continuously tested, monitored, and the feedback will go to the developers. Okay, this is the error I got while deploying or testing. So that will go back to the developer, and they will correct the code at the back end. I mean, whatever the tools like GitHub or source code management tool that they have. So they does the coding change there. Again, they will merge it with the um, what is that? So merge it in the GitHub master branch, and from there code will be picked up and integrated again, and again it will go on testing, monitoring, feedback. So if all these first 4 paces are successful, it will go under the deployment. After deploying, it will be merged in the production environment. After it is live, the operation works begin. Okay. So there are no chances of human error because everything are automated properly. Okay, from code development, the chances are there developers might miss some colon or comma apostrophe. Okay, that might end up in some errors. Uh, but after that, there are no room for the human error here. Okay, so this is the life cycle. So when you type Google, also you will get this picture. But I'll share this slides with you. You can have this for reference. So these are the 7 phases of DevOps lifecycle. So any question here, guys?
No, sir. No.
Okay. So you can compare this with the manufacturing unit also. Like most of the parts comes from different what OEMs. Say for a bicycle assembly unit, uh, wheel should be manufactured by someone. Nuts bolts are manufactured by someone. Seats are manufactured by someone. Engine manufactured by a different OEM. So a company like for example, like let's take Hero Honda. Now it is Honda, I guess, only Hero or Honda. Let's take Hero for example. So wheels, that wheel is different. The tire might be from MRF. The manufacturer is different, and the what that wheelbase is manufactured by someone. Brakes is manufactured by a different OEM. So what they'll do is they do the testing. Okay, first after the manufacture of tire, their team only has a different testing team. After the testing passed, so that will come to the factory, one single factory for the assembling. Okay, consider that factory as a infrastructure which holds all the product together, and from there it will assemble. That is the continuous integration. Okay, after assembling also they'll do the testing, basic, I mean complete check, and then they'll uh, uh, give it to the showroom for the delivery. So once it is in showroom, let's say that is the testing environment. Okay, so first of all, out of 100 what out of 100 customer base, 20 or 30 will be given this particular one for the testing, and then that will be merged in the production. So after we taken the delivery for our purpose, so that is the production environment. And then after sometimes we need to service the vehicle, do the maintenance like petrol, oil change. So all these things are after production operations stuffs that we will do. Okay, that's just a layman example I'm giving here, uh, just for your understanding. Yeah. So what is the continuous integration? So continuous integration is a software development practice where developers regularly merge their code changes into a central repository, triggering automated builds and test to detect integration issues early. It's a code DevOps principle focused on frequent code integration, automated builds, and testing to improve software quality and development speed. Okay, so DevOps here in this continuous integration, so all the codes that developers are merging into the repository will trigger a build. Okay, what Jenkins or the other CI tools do is it will go and read that code and start building the tool. Okay, so after it builds, it will test it. Okay, and after testing, it will say it is ready for the delivery. Okay, so this is the integration. So integration phase, it will read the code after developer merge the code in the central repository, and then this will go and build the tool and test it to find the defects. Okay, so there are a lot of tools. Jenkins is the open source and widely used. So we, for our learning purpose also, will do the Jenkins. We'll learn the Jenkins. Okay, any doubt here, guys?
Sir, no, sir. Is, you have to do manually, or is it an automation?
Yeah, that we
Whether
will
the
see.
changes will be automated.
We will see. We will see all those things. Okay, it's a
Yeah.
doubt that everybody has. So let us say Git, GitHub. Okay, so in Git, what developers do is they'll write the code. Correct. So in Git also they have their own branch and the master branch. You understood? So let's say now we all three are developers. Okay, So there is a central repository uh, for all the codes. So we three have our own repository to write the code. Okay. So what we will do, for our given repository, we will write the code and we will merge it with the central repository. So from the central repository, once we can set the frequency in Jenkins, how frequently it should read the code or after an event is triggered or something like that. So at that point, once Jenkins understand that there is an event, it will go and read the code and fetch the code, and it start building in this build tool. Okay. After it builds, it will do the testing. Understood, guys?
Okay.
Okay. So that is the continuous integration. Yeah. Okay. I explained it to you without the slide. Okay, so GitHub is the repository, like I said, where developers write their code and merge it with the centralized repository. Okay, so code changes might happen every day or once in a week or twice in a day. It is subjected to change, right? So morning my client will give me an instruction to have this picture here, and evening they'll come and say change the logo. Okay, so I need to be prepared for that, so I'll do the code changes every now and then. Okay, so once the code is ready and merged with the centralized repository, this build tool will read the code and it start building the tool. Okay, so before it gets deployed in the production server or before it is rolled out, so it is called as artifacts. Okay, so when we say artifacts, it is not live yet, it is under after testing it is ready to merge it with the production environment. Okay, so when I say artifact, it is not a software which is available for the usage. Okay, software is different, artifacts is something which is still under the building stage, okay, or after it is built. Okay, so before it moved to a production stage, it is called as artifacts. So code will be built, test and evaluate and generate as a software which is called as artifacts. So here while building any while building the code, any errors will be notified to the developers. Again, they will rewrite the code. Okay, this happens as a continuous loop. Okay, so artifacts are stored in a repo. There is a repo for that also. So it will be stored. So if it is a Java based, then it is like the format will be WAR or JAR. So if it is Windows, these are all the formats: DLL, EXE, MSI. So maybe in Windows you might have installed some software in EXE format, right? So this is one of the format. So other formats are also here. So the testing team, it is mostly automated. This they'll undergo these artifacts. Okay, at this point it is called as artifacts. So this will undergo a testing in the server. Okay, and once it is validated or approved, it will merge into the production. After it merges into the production, it is called as the pure software. Understood, guys?
Yes, sir.
Yeah. So this is the loop. So uh, code, fetch. So it is going in anti-clockwise. Okay. So code, fetch, build, test, notify, feedback, and it goes as a loop. Okay. So tools. What are all the tools that are available? So Eclipse, Visual Studio, Atom, PyCharm. These are all the integrated development environment tools. So you can will learn it. Okay, so these are all some of the tools that we use to write codes, or we can easily drag and drop some of the options available there. Source code management, version control is the source code management. So Git, SVN, TS, TFS, Perforce, these are some of the source code management. This is where the developers go and write their code and maintain in the repository. Okay, that's the source code management. And build tools, Maven and Gradle. So these are on the list: MS Build, Visual Build. These are all the build tools. So after we merge it, we merge the code with the what, central repository. These are all the tools will come into picture to build the particular code as a artifact. So software repository. So artifacts are stored in this repository like Sonatype, Nexus, JFrog, Archiva, Cloudsmith package, Grunt. And the CI tools we already saw in the previous slide: Jenkins, Circle CI, TeamCity, Bamboo, Cruise Control. But Jenkins is the open source. We will widely use Jenkins. Even my previous client, they used Jenkins in their environment because it's all open source. It does its job properly. Okay, continuous delivery. Okay, any questions here, guys? Just a tools that you want to know. We will learn about most of these tools in our, not most of the tools, mostly one or two of these tools from each section in our during our learning.
Okay, sir.
Okay, so continuous delivery. So continuous delivery is just an extension or the upstream of the continuous integration. So continuous delivery is the software engineering approach where code changes are automatically built, tested, and prepared for release to production, enabled release to the production. Okay, so enabling frequency and reliable software. So this is something area continuation of continuous integration. So this will be more focused on the release part. Okay, merging into the production part. So you guys just have to understand the terminologies when someone say continuous integration, which area it works, and continuous delivery, which area, automation, artifacts. So these are some of the basic terminologies, but during this course we will learn a lot of terminologies, okay, which helps you to understand what is what and which pace that someone is talking. Okay, so fine. So like I said, agile and operations, agile coding things were automated and coding things went without any challenges, but operation side of it, they had a lot of challenges. So for addressing that, DevOps model comes into picture. So those challenges are where, okay, so ops team gets multiple requests to deploy the artifacts. So operation team say, like I said, morning customer gives a requirement, afternoon he gives another requirement. So developers are enabled to make the changes, but not the operation teams. So they are a bit confused if morning some changes are coming in, evening some changes are coming in. They are unsure what to do, what changes to be done first, what changes to be done second. And there won't be any time for the planning, right? So planning they cannot do when request comes goes very frequently. So after the deployment, chances are there for the server crash, or like I said, when I have the capacity of 200 to store 200 GB of data, if I am already utilizing 180 GB, when the new requirement comes for 50 GB, so my server doesn't have capacity to handle that. So chances are there that it will crash. So auto scaling group, enabling the auto scaling group, it will on the go, it will fetch some 50 or 100 GB. That gives space for the new requirement. Okay. So this is one of the challenge. So deployment failure, higher recovery time. So when they merge the code into the production environment, chances are there crashes might happen. Okay, so there are no way that someone will recover the software after it crashes. Okay, in a very short time, it may takes uh, days, times, even months to recover from that. Okay, so I think recently last year we had a, not last year, Salesforce had a downtime for one entire night. We did not had that Salesforce access, so they were able to recover in within 24 hours. That means they were following DevOps. Okay, they might have merged something new to the production environment that might crash. Okay, so what they would have done is they would have identified that particular what uh, mistake that they have done, and they might have fixed it, or they might have rolled back to the previous build. Okay, so you will understand when we go through Jenkins. Okay, so yeah, so development and operation team has to work together to fix this failure. So that will take a lot of time. So the communication and collaboration has improvised in DevOps concept. So deployment. So what is the responsibility of the deployment team is server provision. Okay, dependencies. Okay, when I say dependencies, so what are all the other hardware requirements, software requirement to make this smooth deployment. Okay, so there are a lot. We'll learn it. So any configuration changes, say they would have write some scripting on the server to accommodate the previous requirement but not the recent one, so they have to go and do a lot of config changes. Okay, and then network. So if when they are adding a new server, then there will be a lot of network requirement is there, so they need to buy another server if it is a physical server, and a rack server, and they need to use some of the networking things like RJ45 socket, more power adapters, more server racks, more servers. So all those things are there. So artifact deploy, so storing the artifacts in the repository, they need to maintain that also there. Okay, you guys with me, right?
Yes, sir.
Okay, okay. And the test automation. So um, so testing team also has to do a lot of functional job, balance the load, performance, database. So all those things are there. Okay, so these are all the challenges faced in agile environment, and the development teams. Some of the roles, some of the responsibility of this, and for test, some of these responsibility of this. So in the continuous delivery, uh, after this code build, code analysis. Okay, this is a duplicate. So after these automation, these are also automated. Okay, so when the code analysis is done and it is deployed into the testing environment. Okay, so the deploy automation, database or security, any changes, software testing, till merging it to the production, it is all automated in the continuous delivery. Okay, understood. So these are some of the automation tool, Ansible, Puppet, Chef, uh, Terraform. So Jenkins continuous, it does continuous delivery job as well as continuous integration job. Okay. So Terraform is the infrastructure automation. Say for example, You don't have to think too much about now, but people learn more when we learn the AWS and Jenkins. We'll learn each and every step. This is just for your understanding. I'm giving the overall picture. Okay. So Terraform, what it does is we need to write some automation scripting there. Okay. So when AWS instance is being spinned up, or after an event is triggered to spin up an AWS instance, we will give the requirement in the Terraform. Okay. When the instance is spinned up in AWS, I need ABC tools to be installed there already. Okay. So that is one of the automation that I can tell you right now, which is easy also. Okay, because every time after a instance is being spinned up, I cannot manually go and install ABC software of it. So let's say Jenkins is triggering an event. Okay, a software is on your way. So that triggers an event, and this Terraform, what it does, it will execute and spin up an instance. And while spinning up the instance, all the softwares will be installed automatically that are required for that particular requirement. Okay. Okay. We'll install few labs today, and tomorrow also it may take some time for us to install. So Oracle, VM, VirtualBox, Git, Vagrant, Chocolatey, or Brew. So Oracle is the VM. So what we are going to do is we are going to use your laptop as a server. So in that we are going to use install Oracle VM, uh, and we are going to install two of the operating system. One is CentOS and another one is Ubuntu. Okay, because one is Debian based, another one is package manager PKG based. So Git Vagrant is the uh, automation. It's another automation tool which will uh, like install the virtual boxes automatically. Okay, so we don't have to do each and every step. Just by writing some 10-liner script, by executing that, it will spin up a VM. Okay. uh, Chocolately, Chocolately is one of the package manager. So when you install that in your system, you can just uh, write some command and install the softwares. Okay, you don't have to download, install in your system. Just open the PowerShell or command line by executing few commands from Chocolately uh, uh, server. It will get installed directly in your system. So it's easy way of doing it. So that is for Windows, and Brew is for Mac. And that those are all the tools right now we are going to install. And this JDK, Maven, IntelliJ, Sublime, AWS CLI. So those tools we will use during our course. And we need to sign up on GitHub. Okay, that's the source code management. We need to register and buy a domain for low price. Okay, so I have already done that. One testing, some 150 200 rupees they will charge. So for testing purpose we need to buy a domain. And Docker Hub, Sonar Cloud, so we need to sign up on this account. So while we sign up for Sonar Cloud, we need to have our GitHub account open in a separate browser, and we need to give access to the access to GitHub from Sonar Cloud. Okay. So AWS, we for now we are going to open a free account. We're just going to do three things. We are going to create a test user, okay, with some MFA, multi-factor authentication. So we're going to create a billing alarm. Though it is free, most of the resources are free. Few of the resources they will charge after a certain period. So that will be bare minimum. So last month I got 116 rupees a bill for my AWS usage, but I was using some 50 GB, two instances, two servers I was using, but I only got 100 rupees bill. And the certificate setup. So for the test domain that we are going to create, so we are going to create a free certificate from AWS and attach it to that domain. So HTTPS. So um, so like GoDaddy provides security, but that involves some cost, as far as I know. But AWS provides the certificate free of cost. So we are going to create a certificate there and attach it to our domain. Okay, so that will give us a secure thing. Okay, shall we do that?
Yes, sir, we do.
Sir,
Okay. Okay, so I will give you access to this one. Okay, so this has step by step for each both Windows and Mac. So after installing Chocolately, okay, you should run your open your PowerShell as an administrator and execute. Okay, execute these commands. So after it is done, we'll see in the next step. I think yesterday I sent to a different